For today's video, we will answer a math challenge given by one of our followers. And the question goes like this. Given these two equations, a squared minus b equals 73 and b squared minus a equals 73 also, then our goal is to find the numerical values of a and b. Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if you get the correct answer. Alright, so what we're going to do is to use these two equations to answer this question. And one thing to notice here is they are both equal to 73. Therefore, we can equate a squared minus b and b squared minus a like this. Because again, they are both equal to 73. Now, what we're going to do is to add b on both sides. And then let's subtract b squared on both sides. Like this. Now, negative a plus b, we can factor out negative 1. If we do that, we got negative of a minus b. Now, take note. When we distribute negative 1 to a, this will give us negative a, and negative 1 times negative b, this will give us positive b. So we are going back to our original equation, negative a plus b. Alright? Now let's factor out this again with negative of a minus b. Now, the reason behind this factoring is we have here a squared minus b squared, and we know we can factor this as a minus b multiplied by a plus b. And notice we have a common factor of a minus b, but don't cancel out or don't divide both sides by a minus b. Alright? So, to answer this, what we're going to do is to equate this to 0. That's the correct step for this one. Don't divide both sides by a minus b because you eliminate one of the possible cases. Now, since we have equal to 0, we can now factor out the common factor a plus minus b. And if we do that, we get something like a minus b. This is our common factor. Now, if we factor out a minus b in this term, we get a plus b. This is a plus b. And if we factor out a minus b in this term, we left with imaginary 1. That's why we have 1 here. Now, let's have the factored form. And since it is equal to 0, using the 0 property, we can say that a minus b equals to 0 or a plus b plus 1 equals 0. So we have two possible cases here, the first case and the second case. Now, in the first case, we can say that a equals b because a minus b equals to 0. And in the second case, we can say that a equals negative b minus 1. So we will do these two separate cases. Now, let's start with the case 1, wherein a equals b. Now, to solve for the values of a and b, let's choose the second equation. Alright, so let's get the second equation. Now, we know that a equals b based on case number 1, so we can replace this a with the variable b because they are just the same thing. And now, let's equate this to 0. So we have b squared minus b minus 73 equals 0. This is a quadratic equation and we cannot factor out this equation. So we will use the quadratic formula. And if we use the quadratic formula, we get something like negative of negative 1 plus or minus negative 1 squared minus 4 times 1 times negative 73 all over 2 times 1. This is very famous formula, the quadratic formula. Now, if we simplify this, we get something like b equals 1 plus or minus square root of 293 over 2. This is the value of b. Now, since case 1 says that a equals b, so we can say that a must be also equal to 1 plus or minus square root of 293 all over 2. So, if a equals 1 plus square root of 293 over 2, b is also equal to 1 plus square root of 293 over 2, and so on and so forth. Alright, so for case number 1, we get two possible pairs for a and b. Now, how about for case number 2, wherein a equals negative b minus 1? Again, let's use the second equation. And now, let's replace this a with negative b minus 1. So again, don't forget to write a parenthesis. Because we will distribute this negative sign, so negative times negative b, this will become positive b, and negative times negative 1, this becomes positive 1. Now, subtract 73 on both sides. If we subtract 73 on both sides, we get b squared plus b minus 72 equals 0. Now, this is easy to factor because we know 9 times negative 8, this will give us negative 72. And 9 plus negative 8, this will give us positive 1. So we can factor this as follows. We have b plus 9 multiplied by b minus 8. So this is the factored form of this quadratic equation. Now let's have the factored form. And since it is equal to 0, using the 0 property, we can see that b plus 9 equals 0 or b minus 8 equals 0. Now, on this case, we can say that b equals negative 9. And on this case, we can say that b equals 8. Now, since a equals negative b minus 1, if this b is negative 9, negative of negative 9 minus 1, so we can say that a equals 8. If b is negative 9, a must be equal to 8. And if b is 9, so we have negative 8 minus 1. So negative 8 minus 1, a must be equal to negative 9. So if b is 8, a equals negative 9. So for case number 2, we also get two possible pairs of a and b. If a is 8, b equals negative 9. And if a is negative 9, b equals 8. And that is the values of a and b that satisfies this given equation. A squared minus b equals 73, and b squared minus a equals 73. And as always, we are done. Now, for your practice, let's have this equation: x squared minus y equals 11, and y squared minus x equals 11. Now, solve for all possible values of x and y. Now, don't forget to show your solution and comment your answer in the comment section down below. Alright?